In this lecture, we will go over dividing a polynomial by a monomial. To divide a polynomial by a monomial, divide each term of the polynomial by the monomial. A plus b over c equals a over c plus b over c. So depending on how many terms you have in your numerator, you will distribute your denominator that many times. Let's first learn how to simplify. Let me get the pen here. I have 4x over 4x. The numerator and denominator are exactly same. They will cancel each other out. So if I try to simplify 4x over 4x, that should give me 1. I have 6x to the 5th over 2x to the 3rd. In this case, I'm going to first reduce the number. 2 goes into 6 3 times. And the exponents, first I see where my exponent is higher. In this case, 5 is higher, which is in my numerator. Therefore, my x stays in the numerator. Because you're dividing, you will subtract your power. 5 minus 3, the exponent will be 2. Let's try another one. 12x to the 7 over 18x. 12 and 18 both you will divide by 6. So 12 divided by 6 will give you 2, and 18 divided by 6 will give you 3. Now once again, you have x here. If there is no number, it's 1. 7 and 1, 7 is a higher exponent, which is on the top. So you will keep the x on the top, subtract the powers, 7 minus 1. We're using here quotient rule. Whenever you divide, you're subtracting. Remember, when the base is same. Let's try one more. 5x to the 6 over 3x to the 9. In this case, I cannot reduce 5 over 3, so I will write 5 over 3 as 5 over 3. But this time the 9 is higher than the 6. 9 is in my denominator, and therefore my x stays in the denominator, and you will still subtract 9 minus 6, which will give you 3. So your final answer will be 5 over 3x to the 3. So when I will divide my polynomial by a monomial, I will use this technique to simplify. Let's divide 6x to the 4 plus 18x to the 7 over 3x squared. Now first I'm going to distribute my 3x squared to the term 6x to the 4 and 18x to the 7. Let's rewrite. Once you rewrite, then you will start reducing. 3 goes into 6 twice, and you will have the power remaining on the top because 4 is higher than the 2. So you will subtract 4 minus 2, that will give you x to the power 2. Similarly, reducing 3 and 18. 3 directly goes into 18 6 times. Once again, 7 is higher than 2. And therefore, subtracting 7 minus 2, you will get x to the power 5 in your numerator. The final answer will be 2x to the 2 plus 6x to the 5. Now you can see that the terms are unlike, meaning the variable or either exponents, they don't match. We cannot combine the like terms. This is going to be our final answer, 2x squared plus 6x to the 5. Let's see some more examples. This time I have 3 terms on the top and 1 on the bottom. 50m to the 4 minus 30m cubed plus 20m over 10m cubed. I'm going to distribute my denominator 10m cubed 3 times. Let's do that first. Once you do that, we will reduce the numbers and we will use the quotient rule on the variables. Let's get started. So 10 goes into 50 5 times. your m should stay on the top because your 4 is higher than 3. 10 goes into 30 here 3 times. Now in this case, m cube and m cube will cancel each other out because they're exactly same. It will be 1. So basically 3 times 1 will stay as 3. 10 goes into 20 twice, and this time my m will stay on the bottom because 3 is higher than 1. So when I subtract, my denominator will be m squared on the bottom. So my final answer looks like this, 5m to the power 1, because I did 4 minus 3. Now you can leave 1 here or simply 5m. It will be correct. So this will be 3 times. When the m cancels 3 times 1, I left with the 3. And 10 goes into 20 twice, and I subtracted 3 in power 1, and that's how I end up having power 2 on the bottom. So use a remembering quotient rule. You want to keep the exponent depending on wherever it's higher, so we don't end up having a negative power in our answer. Let's try a few more examples. In this example, what is different is that my denominator is negative 2x. So first of all, when I rewrite, I will distribute my denominator sign on the top. Therefore, I will have my denominator positive. So when I distribute, you will see that I tried the positive times a negative, which is giving me a negative. Here, a negative right there and a negative right here, that changed the positive. And the last one, a negative times a negative again, that becomes a positive. So as you can see that I distributed the negative sign and all my denominators became positive. Now I will do the same thing again, reduce the numbers and taking care of the exponent using a quotient rule. This is what I get. 2 goes into 60, 30 times, right there, negative 30. 4 is higher than 1, so you have 4 minus 1, x to the 3. 2 goes into 20, 10 times. 2 is higher than 1, 2 minus 1 is 1, or you can simply write 10x. X and x cancel right there, so it's just 1. 2 goes into 10, 5 times, or you can just do 5 times 1, and you see the answer is 5. So whenever you have a negative denominator, make sure you first distribute that on the top. Basically, I switched the sign. The positive became negative right here. The negative became positive, and the negative here became positive. Let's try one more with the negative denominator. Here we go. So in this case, one more time, first of all, I'm going to distribute. This first term right here is going to become negative. Second term will become positive. The third term will become negative. When you switch the sign, the denominator will change into a positive. So as you can see, that's what I did. Negative 12y to the 5 over 6y squared plus 4y to the 4 over 6y squared minus 6 over 6y cubed over y squared. Now let's see how we get the answer. 6 goes into 12 twice, and therefore you see the negative 2. The y stays on the top 3 times because 5 minus 2. 4 and 6 you can reduce by 2. That will give you 4 divided by 2 is 2. 6 divided by 2 is 3. 4 is higher, so 4 minus 2, that's how you get your y squared. In the last term, 6 and 6 got cancelled, so it's only y left. 3 minus 2, that's y. You can write as a 1y there. You can put the 1y in the front, which is the same thing as a negative y. Let's try one more example. Here I have 1, 2, 3, 4, 5 terms over the 3k. I'm going to distribute my 3k to all the 5 terms on my top. Here I would not change my sign because my denominator is positive. So here we go. Now let's see how we get the answer. 3 goes into 27 here 9 times, and that's why you're seeing a 9. K to the 4 and 1. 4 minus 1, that will give you k cubed. 3 goes into 36 12 times. And then k to the 3, and you have 1, and that's how you get k squared on the top. 3 goes into 6 twice. K to the power 2 and 1, that should be k1 or simply k, negative 2k. When they're exactly same, everything cancels. When everything cancels, make sure you write the 1. And the last term right here, you cannot reduce, or there's no other k, so that will stay as is. And that is your final answer. If needed, you can review this lecture again.